Welcome to our countdown of the top likely JAMB 2025 mathematics questions and answers. I'm excited to be partnering with Utmeblog to help you prepare for this important exam. We know that math can sometimes feel a little daunting, but it shouldn't. Our goal is to break down these challenging concepts into bite-sized pieces. We'll be covering 10 key areas in JAMB mathematics, from algebra to calculus. Don't worry, we'll be going through each topic step by step, just like we do at Khan Academy. We'll start with the fundamentals and gradually build up to more complex problems. Remember, the key is to understand the underlying concepts and not just memorize formulas. Make sure to visit utmeblog.com for more detailed explanations and study resources. You'll find practice questions, helpful videos, and even more tips to boost your confidence for the exam. Let's get started. Let's start with the foundation of much of mathematics, algebraic expressions. Think of algebra as a language, a way to describe relationships using letters and symbols. These letters or variables represent unknown quantities, and our job is to manipulate them to find solutions. For example, we might have an expression like 2x plus 5. Here, x is our variable. We can then perform operations on this expression like adding, subtracting, multiplying, or even dividing by other expressions. Understanding algebraic expressions is crucial for solving equations, which are basically statements that two expressions are equal. You'll encounter equations in many different forms throughout your math journey, but don't let the symbols intimidate you. With a little practice, you'll become fluent in this new language, and you'll see that algebra is really just a set of logical rules. Now let's try simplifying a few expressions together to get comfortable with the basics. Remember, practice makes perfect. Next up, we have quadratic equations, which sound really complicated but are actually quite manageable. A quadratic equation is any equation that can be rearranged into the form ax squared plus bx plus c equals 0, where a, b, and c are constants. The key to solving quadratic equations is understanding that they can have up to two solutions, also known as roots. One of the most common methods for finding these roots is using the quadratic formula. Now, the quadratic formula might seem a bit intimidating at first, but it's really just a matter of plugging in the values of a, b, and c from your equation. And once you've practiced it a few times, you'll be surprised how easy it becomes. But the beauty of quadratic equations goes beyond just solving for x. They have real-world applications in fields like physics, engineering, and even economics. For instance, quadratic equations can be used to model the trajectory of a projectile, the shape of a parabolic mirror, or even the relationship between supply and demand in a market. Now let's dive into the world of trigonometry, which deals with the relationships between the angles and sides of triangles. Trigonometric identities are like special equations that are always true for any angle. These identities might seem like a lot to memorize, but they're actually incredibly useful for simplifying trigonometric expressions and solving trigonometric equations. Think of them as shortcuts that can save you a lot of time and effort. Some of the most common trigonometric identities include the Pythagorean identity, sine squared theta plus cosine squared theta equals 1, the double angle identities, and the sum to product identities. Each identity provides a different way to express trigonometric functions in terms of others. Understanding trigonometric identities is essential for solving problems involving angles, distances, and periodic phenomena. You'll encounter these concepts in fields like navigation, astronomy, music, and even signal processing. So, take your time to understand the relationships between the different trigonometric functions and how these identities can help you simplify complex expressions. Now, let's move on to calculus, a branch of mathematics that deals with change. It might sound intimidating, but it's really just a set of tools for understanding how things change over time or in relation to each other. Calculus is divided into two main branches, differential calculus and integral calculus. Differential calculus deals with the instantaneous rate of change, or how fast something is changing at a particular moment. This is where the concept of a derivative comes in. On the other hand, integral calculus deals with the accumulation of quantities or how much something has changed over a period of time. This is where the concept of an integral comes in. While calculus might seem abstract at first, its applications are incredibly practical. It's used in fields like physics to model motion, in engineering to design structures, and even in economics to analyze market trends. Don't be afraid to dive into the world of calculus. It's a challenging but rewarding subject that will deepen your understanding of the world around you. Let's not forget about geometry, the study of shapes, sizes, and the properties of space. Understanding geometric shapes is about more than just knowing their names. It's about recognizing their properties and how those properties relate to one another. We'll explore different types of triangles, quadrilaterals, circles, and solid figures. We'll learn about their angles, sides, areas, and volumes. And we'll discover how these properties can be used to solve problems in fields like architecture, engineering, and design. For instance, understanding the properties of triangles is essential for architects when designing stable structures, while engineers rely on the principles of geometry to design bridges, roads, and other infrastructure. So don't underestimate the importance of geometry. It's a fundamental subject that has applications in countless fields. Let's explore the fascinating world of probability, which is all about understanding and quantifying uncertainty. Probability helps us make decisions in the face of randomness and predict the likelihood of events. We'll learn about basic probability concepts like sample spaces, events, and the rules of probability. We'll also explore different types of probability distributions which describe the probabilities of different outcomes in a random experiment. Probability is used in a wide range of fields from finance and insurance to medicine and meteorology. For example, financial analysts use probability to assess investment risks, while meteorologists use it to forecast weather patterns. So even if you don't consider yourself a gambler, understanding probability can help you make more informed decisions in many aspects of your life. Now let's talk about sequences and series, which involve patterns of numbers. A sequence is simply a list of numbers that follow a specific rule or pattern, while a series is the sum of the terms in a sequence. We'll explore different types of sequences and series like arithmetic sequences, geometric sequences, and Fibonacci sequences. We'll learn how to find the nth term of a sequence, the sum of a series, and how to determine whether a series converges or diverges. Understanding sequences and series is not just about crunching numbers, it's about recognizing patterns and using them to make predictions. These concepts are used in various fields, including computer science, finance, and even music. So keep an eye out for patterns in the world around you. You never know where a sequence or series might pop up. Let's dive into the world of matrices, which are powerful tools for organizing and manipulating data. A matrix is essentially a rectangular array of numbers arranged in rows and columns. We'll learn about different types of matrices, how to perform operations on them like addition, subtraction, multiplication, and how to find the inverse of a matrix. Don't worry, it's all very logical, and with practice you'll get the hang of it. Now you might be wondering, why are matrices so important? Well, they have applications in a wide range of fields including computer graphics, cryptography, and economics. For example, in computer graphics, matrices are used to represent transformations like rotations and translations. In cryptography, matrices are used to encrypt and decrypt messages. And in economics, matrices are used to solve systems of linear equations, which can model things like supply and demand or input-output relationships in an economy. So, don't underestimate the power of matrices. They might seem a bit abstract at first, but they are incredibly useful tools for solving real-world problems. Finally, let's explore the world of statistics, which is all about collecting, organizing, analyzing, interpreting, and presenting data. In today's data-driven world, understanding statistics is more important than ever. We'll cover essential statistical concepts like measures of central tendency, mean, median, mode, measures of dispersion, range, variance, standard deviation, probability distributions, and hypothesis testing. These concepts help us make sense of data, identify trends, and draw meaningful conclusions. Statistics is used in countless fields, from healthcare and business to social sciences and government. For example, medical researchers use statistics to analyze clinical trial data, while businesses use it to understand customer behavior and make informed marketing decisions. So, whether you're interested in a career in data science, or just want to be a more informed citizen, understanding statistics is crucial. Let's wrap things up with functions and graphs. A function is essentially a rule that assigns a unique output value for each input value. Think of it like a machine. You put something in and it spits something out based on a specific rule. Graphs, on the other hand, are visual representations of functions. They help us understand the relationship between input and output values more intuitively. We'll explore different types of functions like linear functions, quadratic functions, exponential functions, and trigonometric functions. We'll learn how to graph these functions, identify their key features, and interpret their behavior. Understanding functions and graphs is crucial for modeling real-world phenomena, from the growth of populations to the motion of objects. So be sure to spend some time getting comfortable with these concepts. They are fundamental to many areas of mathematics and have applications in countless fields. Thanks for watching. I hope these insights into the 10 likely JAMB 2025 mathematics questions have been helpful. Remember, the key to success in math is to break down complex concepts into smaller, more manageable pieces. Don't forget to check out Utmeblog.com for more JAMB 2025 preparation tips and resources. You'll find practice questions, in-depth explanations, and additional strategies to help you build your confidence and ace that exam. Good luck with your studies and exams. Remember, with hard work, dedication, and the right resources, you can achieve anything you set your mind to.